Okay, so yeah, we will start the discussion of queues. We will understand the queues in system Verilog with the help of coding. Wait a minute. So they are basically two types of queues. One, first of all, let me declare a module called queue underscore test, and so they are basically two types of queues. First one is bounded queues. So I will declare a bounded queue. The syntax for bounded queue, I will take int data type, and the queue symbol is dollar followed by 5. So basically queues are not bounded, but we can also declare a bounded queue by using the syntax like this. So this queue can only store 5 elements, and there is another type of queue which is unbounded queue. Syntax for this is q, let's say this is q2 dollar. So these are two types of queues. One is bounded queue and another is unbounded queue. And within an initial beginning block, wait a minute. So within an initial begin and block, I will assign q1 is equal to 1 2 3 4 5, and q2 is equal to 2 3 4 5 6, and I will display the values of q1 and q2. $display the elements. First of all, I will display the size of the queue. Size of the q1 is percentage d comma q1 dot size, and I will display the size of q2 also. The size of the q2 is percentage d comma q2 dot size, and next I will display the elements of q1 and q2. $display the elements in q1 are percentage p comma q1, and I will display the elements of q2 also. Wait a minute, let me copy this and paste it over here. The elements in q1 are percentage p, and elements of q2 are also percentage p and q2. And let me end this statement and end the module. So let's see what we are getting here. So the console, we can see the size of the q1 is 5 and the size of q2 is also 5, and q1 are 1 2 3 4 5 and q2 are 2 3 4 5 6. So these are the queues which I have declared. Now let me end this simulation. And now what I will do is insert some elements into this q1, which is bounded queue. Let's see what happens here. q1 dot insert, so 2 comma 5. So 2 is the index and 5 is the element. 2 is the index number and 5 is the element. I will display the value of the elements in q1. Let's see what we are getting, and also I will display the size of q1. The updated size of q1 is percentage d comma q1 dot size. And updated elements of q1 is updated elements of q1 are percentage p comma q1. So let's see what we are getting. And also I will insert some elements in q2 also. So for inserting elements in a particular index, we will use this keyword insert. So q2 dot insert, at position 4 I will insert element 10. I will display the size of the, first I will display the elements, updated elements of q1, elements in q2 are percentage p comma q2, and I will display the size of q2 also. So the updated size I will display, updated size of q2 is percentage d comma q2 dot size. So this I will display. Let's see what I am getting. Let me compile this. So the output we can see the updated elements. So the element previously the elements of q2 are 2, 3, 4, 5 and 6, and the updated elements of and the previous elements of q1 are 1, 2, 3, 4, 5. So now updated elements of q1 are 1, 2, 5, 3, 4 and 5, and the updated size of q1 is 6, and the updated elements in the q2 are 2, 3, 4, 5, 10, 6, and the updated size of q2 is 6. So by the help of inserting method, we will insert a particular element to the queue. And now we will end the simulation. Let me insert one more element here. So let's say q1 dot insert again 2 comma 8, and let's see, let's display the value, dollar display the updated value of q1 is percentage p comma q1, and let us also display the size of q1. So here we can see when we are trying to insert one more element in this q1, that is our q1 is a bounded queue which can store only 0 to 5 elements, that is total 6 elements it can store, but I am trying to insert another one more element in the index 2, that is 8, but at the console I can see a warning stating that queue operation would exceed maximum write index of 5. So like this we will get an error when we try to store more values greater than the declared size in the case of bounded queues, whereas in case of unbounded queues we can store as many as values we can. So this is the difference between the bounded and unbounded queues, and this is how we will insert a particular element in the particular index in a queue. So if we want to delete a particular element from the queue from a particular index, we will use the keyword delete. So I will delete say 8 from the, so I will delete the element 8 from the q1, and I will display the updated queue of q1 after, it should be in quotes, after delete operation is percentage p comma q1. and also I will delete 10 from the Q2. So Q2 dot delete 10. So it will find out the 10 in the queue and it will delete it. I will copy this. So from the Q2, after delete operation is percentage %p, comma Q2. So this is the delete operation and insert operation in the queue. Let's see one more operation and then we'll check the outputs. So for pushing any element into the queue in the front, we have already discussed in the theory. We can use push underscore front function, and I want to insert 11 in the Q1 and I'll display this. The updated Q1 after push underscore front operation is percentage %p, comma Q1. And if I want to remove any element from the queue, then I will use the operation pop. So pop underscore, wait a minute, I will first push one more element into this queue, q2 dot push underscore front of I will insert 12 to this queue and I will display this. So the updated value of q2 after push underscore front operation is percentage %p, comma q2. So I am performing push underscore front. Basically it will push the element into the first index of the queue, and here I am performing push underscore front on q1 and q2. So let's check the output. Yeah, let me simulate it. Wait a minute, I'm getting a warning here. Percentage %p, comma what error I'm getting. Let me check here. Wait a minute. I haven't ended this simulation. Let me simulate it again. Sorry, I've used only display. It's $display. Yeah. So let me recompile it. So here we can see initially the value of Q1 is 125345 and Q2 is 234510 and after delete operation I am deleting 1253. Wait a minute. So I'm performing removing delete. So here we can see q1 dot delete 8. So I'm deleting the element 8 from the Q2, but there is no element in 8 in the Q2, so it is not getting anything deleted. So I'm performing push underscore front operation, and I'm pushing element 11 into the Q1. So as it is a bounded queue, no element is being pushed into this Q1, and I'm trying to push uh, wait a minute, I will show this element 12 into the Q2. So at the output we can see the updated Q2 after push underscore front operation is 12. So if I perform push underscore front, then 12 is being pushed into the queue, and it is being placed in the first value. So this is a push underscore front operation in the queues. So is it clear for everyone? If you are having any doubt, you can ask me. So for removing the first element of the queue, then we can use the keyword pop underscore front. So q1 dot pop underscore front, can use this, and I will display this dollar display the updated value of q1 after performing pop operation is percentage p comma q1. And similarly I will perform the pop operation for q2. So q2 dot pop underscore front, and I will display this. So the updated value of q2 after performing pop operation is percentage p comma q2. So this is the pop operation, and we can also push the elements from the back of the queue by using the keyword push underscore back. So I will perform q1 I will perform q2 dot push underscore back, say 20, and I will display this dollar display well, wait a minute. Yeah, the updated value of q2 after performing push underscore back operation is percentage p comma q2. Basically push underscore back will add the element from the back of the queue, and I can remove the element from the back of the queue using pop underscore back. So it will remove the element from the back of the queue. I will display this. So updated value of q2 after performing pop underscore back operation is percentage p comma q2. So let us see what we are getting at the output. So the output, we can see the updated value of q1 after pop operation is 25345. So before popping out, the initial value of q1 was 1254345, and after removing 1 we are getting 25345. And when we are performing pop underscore front on q2, the element 12 is being removed from the queue, and we are getting 234510 6. And we are performing push underscore back operation on the q2. So the element 20 is being added to this q2 from the back. This here it is being placed, and whereas we are performing pop underscore back operation on this q2, so the element 20 is being removed, and this is our output. So this is the push underscore front and push underscore back operations on the queue. So is this clear? you are having any doubt, you can ask me. And there is one more operation called shuffle. So basically it will shuffle the elements of the queue. Q1 dot shuffle. Let me display this also. $display the updated value of Q1 after performing shuffle operation is %p comma Q1, and I will perform Q2 dot shuffle. So it will basically shuffle the elements. So the updated value of Q2.
हेलो
Yeah.
इसमें ऑल ऑपरेशन इंक्लूडेड इन द प्रोग्राम.
Yes.
ओके.
So I'm taking all the inbuilt functions so that we can understand all the operations clearly. Is it clear?
क्लियर.
Yeah. So before seeing shuffle, we will also see one more function called, we have another function called delete. Basically this will delete all the elements of the queue. We'll display this, $display the updated value of Q1 after deleting, delete operation is %p comma Q1, and the value of will also delete all the elements. Delete. Display this, the updated value of Q2 after performing delete operation is %p comma Q. So this is what I'm doing. Let's see our outputs. So at the console we can see the shuffle operation will basically shuffle all the elements. Before that we are having the value of Q1 as 25345. Now we are getting 24535, and similarly with Q2, basically it will shuffle all the elements randomly. It will shuffle all the elements, and if we perform delete operation, it is deleting all the elements of the queue. So with Q1 and Q2, if we use delete operation, Q1 dot delete, it will delete all the elements of Q1 and Q2. So these are some of the built-in functions in our queues in system Verilog. So these are all built-in functions available we can perform with the queue. So this is about today's session. So if you are having any doubt, you can ask me, or else we can end this session.